So you guys might be choosing to do this directly on the document. You might be choosing to do it on paper. I have a paper copy. If you choose to do it on paper, that's totally fine. But we're just going to go through a few problems. If you understand what's going on from my last video, you can go ahead and take over and complete this entry on your own based on that. If you want to walk through it with me, hang in and let's go through a few things. In this problem that we're going to do here, we're talking about Ocean and Lucy. So we're talking about the tail color trait again. Remember that blue is dominant, so we're going to use an uppercase T for blue alleles, and then orange is recessive. That's our lowercase t. So what we're going to do in our first one is we're going to cross Ocean and Lucy together. Remember, Ocean and Lucy are both heterozygous. That means they have a dominant and a recessive allele. But remember, their phenotype, their physical appearance, is blue. They're both blue, but they're not purebred. They have one of each allele. So remember, when you're doing your Punnett square, make sure you know your key. I know that blue is my dominant allele, and then orange is going to be my recessive allele. Once again, we want to take the allele for each parent. It doesn't matter whether mom is on the top or the side. They can be in either place as long as you keep them, their alleles on the same side. So let's say that this is mom. Let's say this is Lucy. She has a dominant allele and a recessive allele, so I split them up. I take dad's and I do the same. His alleles go on the top. Remember to fill out the box. I always pull an allele from mom and I pull an allele from dad, so I always pull from the left and pull from the top. I bring those two letters together. I do the same over here. I pull all the way from the left and from the top. I bring those letters together. I pull from the left and I pull from the top. I do, out of format, always want to write my uppercase letter first. I pull from the left and I pull from the top. Voila. So your first question says, use a blue pencil or a regular pencil to shade in the offspring that would have blue tails. So you need to go back and look. Remember, offspring are in the boxes. Which ones will have a blue tail? Well, blue is dominant. So if they have the dominant allele or the uppercase letter, they will be blue. So these guys should all be blue. So it asks you about what fraction would have blue tails. Well, easy fractions here. There's 4 boxes. 3 of the 4 are going to have blue tails. So your fraction is 3 out of 4. 3/4 will have a blue tail. How many would have orange tails? Well, only one of the boxes has orange tails, so 1 out of the 4 would have orange tails. Okay, so our next problem over here. So we have an orange-tailed critter and a heterozygous blue-tailed critter. Okay, so my orange-tailed critter is up here. Remember, the only way the critter can be orange is if it has 2 recessive alleles. So my orange-tailed critter has 2 lowercase letters, 2 recessive alleles. I'm crossing it with a heterozygous blue-tailed critter. Hetero means they have 1 of each. And I split up my letters on this side. Same thing, you should be getting it by now. I pull from the left and I pull from the top. Pull from the left and from the top. I pull from the left and I pull from the top. And the last one, I pull all the way from the left and I pull from the top. Remember, you're pulling from each side because you got to pull 1 allele from mom and 1 from dad. Everything in the boxes are our offspring from here. So if I look at which ones in there have blue tails right now, those are going to be the ones that have the dominant allele. So remember, offspring in the boxes. So how many of the boxes inside of the offspring are going to have blue tails? Well, you can say 2 out of 4. You can say 1/2. You can say 50%. Those are all fine. And then how many would have orange tails? Well, those are the other 2 out of 4, or 1/2, or 50%. Does not matter to me how you want to write it. All right, this last one's going to look familiar because this is what we did for our very first example. So if you know what you're doing, go ahead and head out and do that. If you need to stick in, go ahead and do that. But what I'm doing in this problem is I am crossing a homozygous dominant critter with a heterozygous critter. Remember, same alleles and they're dominant, different alleles. So I split up my alleles on each side. And then I follow my pattern. Pull from the left and pull from the top. left and top, left and top, but I want to put my dominant one first, left and top, but I want to put my dominant one first. So we've already seen results like this one before. Which ones would have blue tails right now? Well, all of them have the dominant allele. That means all of them are going to be blue. So it says what fraction would have blue tails? Well, you can say 4 out of 4. You can say 100%. How many would have orange tails? In this square, none of them do. 0%. 0 out of 4. However you want to represent that is fine. You guys can go ahead then and use this pattern to complete the analysis questions, then turn it in.